Hello there, it's Karen Greenhouse, and I am doing a video overview of two mini math lessons. They are algebra focused, and they are kind of the beginning stages of inverse functions, helping students visually understand what inverse functions are, and then from there you can explore more. So one's on linear functions, and then one's on power functions. They're very similar activities. Probably good to do them both in order just to kind of show that the inverse functions, as you graph them, have a similar symmetry around the identity function of y equals x. That's what this is all about. So they are going to be using in both activities real-world data. So you're going to be doing scatter plots and regressions, and then writing the equations, and then comparing the equations to the identity function, or the functions to the identity function. So that's where we're going. I'm just going to do a little bit of an overview for both of them, probably a little bit more on the first one because the second one is virtually, I won't say identical, but the same process rather for both. So I'm using ClassPad.net, and that's a free math software. If this is the landing page here, if you scroll down, you can just start playing. I do recommend that you create an account, because if you have an account, then the work you do on these mini math lessons, you can save it, or you can just save the activities themselves and modify them to fit your needs. So an account allows you to save things that you do. If you don't have an account, nothing you do is going to be saved, which makes sense, right? But anyway, ClassPad.net is basically an all-in-one math software. You can do calculations, you can do geometry, you can do graphing, things with functions, inequalities, you can do data. So you're going to see these two in particular in these activities. So it's a nice kind of overview. So let's get started. I'm going to pull up the first activity, and a reminder, the activities are linked in the description of this video. So if you want to, see them yourselves, the links are there. So here's the first one, and it's about importing textiles. So you'll see there's some real data here, and it's comparing the years and the billions of dollars of imports that are coming in from Hong Kong on textiles, so clothing, shoes, those types of things. And so they're going to be making a scatter plot of this first. So if you notice, our independent is going to be the year, and our dependent variable is going to be the billions. And so they're going to make a scatter plot. And again, I'm just walking through things very, kind of quickly. Oh, that is a terrible color. So let's change the color. So you'll notice here's my scatter plot that sort of summarizes what's in the graph. So my independent is year, the dependent is billions, right, from this data. So here's my scatter plot. And then they have to explore, regressions, and it's suggested that they do a linear regression. So they're going to select those two columns again and go to the regression menu. Notice there's lots of regression here, but we're going to do a linear one in this case. And from that regression, then they're going to write their equation that they're going to use. So there's questions here, there's directions, and here's where they answer their questions, and they show their work here. The next section is, okay, well, what happens if you reverse the independent and dependent, or inverse, right? So instead of year being the independent, we're going to make the money, the import dollars, billions, be the independent, and the year the dependent. And what's that graph look like? So they're going to basically do what they did up here, create a scatter plot, do a linear regression, but it will be different, right? Because we have a different independent and dependent, and that's what we're really going to focus on. So by the end of these two little sections, they'll have two different function equations, and that's what they're going to then compare those functions. So this is the beginning idea of what is an inverse function. So we reversed the variables, independent, dependent. So we basically created inverse graphs, regressions. And so what do those equations look like when we plot the equations they came up with, the functions? So I'm just going to do a real quick, just to show you what's going to end up with. So in the first one, they have something. Now I've rounded. I would suggest that they don't round as much as I do, but I'm just trying to do this for time's sake. So here is the equation for the first one. So notice it's, it's a linear equation. This green line is your identity function, so y equals x. And so now we're going to plot the equation they developed in the second when they inversed or switched the independent and dependent variables. And so that equation, again, I rounded, so when they're doing this, we want them to be a little more precise. And so here's the inverse function. And so then they're going to visually compare it to this identity function. What do they notice? Do they look like their mirror? If I flip them, if I have a point on the purple, what would be the inverse point on the other one? Those types of things are what they're going to be exploring. So really, this is just really beginning understanding of what inverse functions are, what they look like graphically, and then you can go further into actually using inverse operations and inverse numbers to find inverse functions. So the second activity, very, very similar. So it's also on real-world data. It's about the length, determining the mass of a fish based on its length versus actually weighing it on a scale. And so there's a lot of data here. You'll see there's 42 different pieces of data here. And so again, just like we did back here in the linear one, they're going to first make a scatter plot where the independent is the length of the fish and the dependent is the mass. And they're going to then try to do a regression there. And they're going to look at different regressions, which one's the best fit. And hopefully by the end, they come up with the fact that a power regression is the best fit. So if I were to actually do that real quick, so scatter plot again. So, and I don't know why it keeps coming up yellow. It's not the best color. You can't see things. Let's do purple. There we go. That's much better. And then, same thing. Select the columns again. Oops. Select those columns again. And this time go into the regression menu. And they're going to try, like we could try linear, or we could try power, quadratic, whatever one seems to work the best. And so, they're going to determine which one seems to be a better fit. And then this is why it's definitely more advanced algebra than just basic algebra. This is where they're going to be looking at the R-squared values and determining which one is a better fit for this data. So once they come up with that, it tends to be the power. Then they're going to do the same thing we did in the last one. They're going to switch the independent and the dependent variables. So now the mass, the weight of the fish is our independent and our length is dependent on that. And so what's that graph looks like, what's that equation, and when they get there, they're going to then very similarly put each of their functions in, which are inverse functions to each other, and then kind of compare visually. So that's what both activities are doing. Again, very much an introduction to what inverse functions look like and, how are they connected to that identity function. How do you know you have an inverse? And then you would then move into more specifics with the inverse operations and the inverse numbers. So have fun.